we have been discussing about three-phase unbalanced system. Okay, in that we can classify the three-phase unbalanced system, or you can distinguish with respect to star and delta connection, and balanced and unbalanced systems, and symmetrical and unsymmetrical systems. So you can classify like this three-phase system. Okay, and this is what the star and delta classification, and symmetrical and unsymmetrical. This is with respect to the phase angle displacement. If the phasors are displaced equally, then you can say it's a symmetrical system. And if the phasors are displaced unequally, then it is unsymmetrical system. And the phasors having different magnitudes is called unbalanced system. Phasors having equal magnitude, then it is called balanced system. That means impedance in all the three phases should be same. If the impedances are same, current will be same. If the impedances are different, then current will be different. So when there are unequal impedances, there will be unequal currents flowing in the phases. So you can call it as unbalanced system. Okay, and we have discussed about the phase sequence. RYB and RBY is based on the counterclockwise direction, and based on the clockwise direction. So it is phase sequence means the sequence in which the phasors reaches the peak value or the trough value, that is crest value or the trough value of their wave. Okay, yes, and the power delivered in case of a system, a three-phase system, can be P is equal to root 3 VL IL cos phi. That is the real power. Reactive power, it is root 3 VL IL sin phi. And apparent power, it is root 3 into VL into IL. This is what the with respect to power delivered. And I want to find the angle. So if you want to find the angle between the two phasors, voltage phasor and the current phasor, take the angle of the voltage with respect to the reference, and take the angle of the current with respect to the reference, and subtract it, you will get the angle phi. So if you take the cosine of the angle, then you will get a power factor. Okay. So in this case, 10 angle 20 is the phasor, voltage phasor, and 10 angle 10 is the current phasor. Okay, 20 degree is the angle of the phase voltage phasor, and 10 degree is the angle of the current phasor with respect to the reference. The angle between them, you can take it as like this, that is 20 minus 10. It happens to be what the 10 degrees, that is cos phi, is cosine of the angle between the voltage and the current. Then it is called as power factor. So in a balanced system, if you find the power in one phase and multiply by 3, you get the total three-phase power. So three-phase power you can find, that is V phase is I phase into cos phi. Then that becomes a single phase power. And because it's a balanced system, you can multiply by 3 to get the total three-phase power. But it does not happen in unbalanced phase. So you have to find the power in the red phase, power in the Y phase, power in the B phase. Then you have to add it to get the total power in the three-phase unbalanced system. Okay, and we also discussed about the different types of unbalanced loads. So you can have a distinction have for having balanced supply and a balanced load. So there are two quantities here. One is balanced load and balanced supply. The supply can be balanced and supply can be unbalanced. Load can be balanced or load can be unbalanced. Usually what we do, we assume that the supply is balanced always. So as a result, we can assume that load can be an unbalanced phasor or unbalanced or balanced system. So the unbalanced loads can be classified into three types, that is 3-wire star connection, 4-wire star connection, and delta connection. In 3-wire star connection, you will not be having neutral. In 4-wire star connection, you will be having neutral. If you want neutral in a three-phase system, you have to go for a star grounded system. Star grounded means what? You will have a ground wire or neutral wire. In delta connection, you will not be having a neutral connection. Clear? Yes. Now, how to analyze this three-phase unbalanced system. So, in this case, the first thing is what three-phase, three-wire star-connected system. That means you will be the star-connected system. That means the supply side is also star-connected and load side is also star-connected. Okay. Supply side is also star-connected and load side is also star-connected. Mm, so the supply side neutral is denoted as O, load side neutral is denoted as N. So there is no connection between O and N. In such a case, the voltage of O and voltage of N is not equal. That means the neutrals of load and supply are not shorted and they are maintained at the different levels. So in this case, how to find these voltages and currents in such a case? So you can use the Millman's theorem and you can use the mesh current or loop current method. So in the last class we have discussed about the Millman's theorem. Millman's theorem is a finding out like this. So it is VA naught into YA, VB naught into YB, VC naught into YC divided by YA plus YB plus YC. That is nothing but voltages finding out between A and 0. A and O is nothing but what the phase voltage of the supply and in A phase VBO. VBO is what the phase voltage on B phase and VCO phase voltage in C phase on the supply side. I repeat, VAO is phase voltage on the supply side in phase A. VBO is phase voltage on B phase on supply side. VCO is phase voltage on C phase on supply side. YA, YB, YC. This YA, YB, YC are admittances in the A, B, and C phase. So here I am denoting the phases are A, B, C. You can denote them as R, Y, B also. It doesn't matter. So you have to use this values contextually. It can be R, Y, B. It can be A, B, C. Like that you can use contextually. Depends on your understanding. Clear? So this is what we have discussed until the last class. So I have not been able to take class because of some exam commitments and personal work. So I will just continue from where I have left. We have to solve problems on the Millman's theorem. Okay. So let us solve problems on Millman's theorem. You can either use Millman's theorem or mesh current method for unbalanced system study. Clear? So we are discussing now the first type. The first type is three-phase three-wire system. Okay. So you can take down the problem. The problem will be of statement type. The problem will be of statement type. You have to make out the data from the statement type. I request somebody to prompt me if the statement is not proper. Yeah. Take down the problem. A symmetrical 440 volts. A symmetrical 440 volts. Three-phase system. Symmetrical 440 volts. Three-phase system. Supplied a star connected load, with branch impedances ZR is equal to 10 ohms, ZY is equal to J5 ohms, and ZB is equal to minus J5 ohms. Okay. So calculate voltage drop voltage drop in each phase. Calculate voltage drop in each phase and the potential difference between neutral and star point, star point. The phase sequence is RYB. The phase sequence is RYB. Also draw the phasor diagram. So if you learn one problem with all conceptual knowledge, then that is sufficient. You can solve any problem on the given day. It is very direct analysis of the problem. There is no twisting and turning of the problems involved here. It is direct if you know the concepts. Okay. So I repeat what is given here. So it's a three-phase system, 440 volts, supplied a star connected load. That means the line voltage is 440 volts. The line voltage is what? 440 volts on the supply side. Okay, what is the line voltage on the 440 volts supply side? It is 440 volts. So ZR is equal to 10 ohms, ZY is equal to J5 ohms, ZB is equal to minus J5 ohms. That means the impedances are unequal. What do you infer? You infer it as an unbalanced load, star connected load. Okay, so this is what you have been given. So you have to write the phasor diagram also in this problem. Clear? So what we shall do, we shall write the network first. So it is a star connected unbalanced load. It's a star connected unbalanced load. So I am writing like this. So I am not writing on the supply side. I am writing on the load side. Okay. So this is what here it is given to be, and this is R, and this is Y, and this is B. So ZR it is given for you. So what is that ZR? It is 10 ohms. ZR is 10 ohms. ZB is J5 ohms, and it's minus J5 ohms, and ZY is J5 ohms. This is given to you. Okay. So I am writing on the load side. I repeat, I am writing on the load side. Okay. So what is that you have to calculate here? You have to calculate the phase voltages on the load side. So what is this point? You can refer this as. So you can refer this as N, that is neutral on the load side. So you have to find the phase voltages. So what is the phase voltage on the load side? What are the phase voltages on the load side? And how do you measure the phase voltage on the load side? You have to measure the phase voltage R with respect to the neutral. So what do you denote this one as? You denote this one as VRN. So if you measure the voltage of Y phase with respect to N, so what is this? It is nothing but VYN. If you measure the voltage with respect to a neutral of B phase, what do you call this as? BN. That means you are connecting voltmeter across an R phase and a neutral, Y phase and a neutral, B phase and a neutral. So you'll be getting this as what? Phase voltages in each branch. This is what you have to find out. Is it clear? So this is what we have to find out. There is a VRN, VYN, and VBN. Also, we have to find out the potential difference between neutral and star point. so that we have to find out neutral and star point. So there's a voltage potential between neutral and star point, neutral of the load and star point of the supply side. So you are supposed to find out VNO. Okay. So from the Millman's theorem, we have got the formula as VNO is equal to, so VNO is all phasors. VNO is equal to what? VRO into YR plus VBO into YB, sorry, VYO. So VYO into YB, sorry, YY, okay, plus VBO into YB. This is the numerator, and the denominator as per my formula YR, YY and YB. That's all. Okay. So this is the formula to find VNO. After finding VNO, you can find the phase voltages on the load side using the neutral shift voltage. This voltage is what? Neutral shift voltage from Millman's theorem. So now you know YR, YB, YY. Why? Because you already know ZR and ZY and ZB. So you can just find this one YR, YY and YB. So YR is nothing but 1 by ZR. YY is nothing but 1 by ZY. YB is nothing but 1 by ZB. This is as good as the admittances and the impedances relationships. Clear? So denominator, you know. So what is that you have to find in this formula? You have to find VRO, VYO, and VBO. What are those? That is the next question. What are those? So VRO, VYO, and VBO. I write here. So it is VRO, VYO, and VBO. What is this? These are what? Again, phasors. So, so it is nothing but what? R to 0. What is that? It is phase voltage on the supply side. Phase voltage on the supply side in phase R. Okay, this is phase voltage on the supply side in phase Y. This is phase voltage on the supply side in phase B. So we have to find out this one. How to find out this one? We know the line voltage. The line voltage is 440 volts on the supply side is given. That means line voltage is given. So you have to find the phase voltages. So we know that. So V phase is equal to V line to line by root 3. This is the actual relationships in a star connected supply system. So V phase is equal to VL by root 3. So what is that you can make here? So it is 440 divided by root 3. I will take R as a reference phasor. So it is angle 0. Okay. It is 440 divided by root 3 is a reference phasor. From the reference, you have got 120 degree apart. It's a symmetrical system. Supply side is assumed to be symmetrical. I repeat, supply side is assumed to be symmetrical. So angle between the R phase and the Y phase is minus the 120 degrees or 120 degrees. Clear? Now, how to find this one? 440 by root 3. And what is the displacement between B and Y, or B and the reference phasor R? It is nothing but 240 degrees. Okay, minus 240 degrees. Okay, so this is what the 440 by root 3. 440 by root 3 is 254.03 angle 0, 254.03 angle minus 120, and 254.03 angle minus 120, or minus 240 can be written as what? Plus 120 degrees, like that you can write. So you can either write it in polar form or rectangle form. So if you have understood so far, please type 0 on the chat box. If you want me to repeat, I will repeat again. Please type quickly. Yeah. So now you got VRO, VYO, VBO. Everything is got. now until now. So just substitute the values here in place of VRO, VYO, VBO, YR, YY, YB divided by this one. So use a calculator and use brackets judiciously wherever it is required. Okay, because if you do not use brackets while using complex number, it may lead to wrong answers. So please try to be focused while you enter the data in the calculator. Clear? So now if you type these values in this formula for VNO, so you will be getting the answers like this. Can somebody type me and get the answer quickly? So, or shall I write the answer? So I write the answer directly because I don't want to waste time here. So it is direct. So VNO happens to be equal to 626 angle 0. VNO happens to be equal to 626 angle 0. Okay. So now this is the neutral shift voltage. It is found out. Next, you are supposed to find VRN. This VRN is equal to VRO plus VON. Okay, so VRO plus VON. Okay, so and also VRO is minus VNO, minus VNO. Okay, similarly VBN is equal to what? VBO plus VON, and is nothing but VBO minus VNO. And similarly VYN, V by N is equal to this V by O plus V O N, V by O minus VN. So you got all the values now. So you will be simplifying it, and you can solve for the answers quickly. Can somebody solve for the answers so that I can validate and move further quickly? Anybody with the answer? Hello, ladies and gentlemen. Hello, Ananya. Hello.
Excuse me, sir.
Yeah,
Sir, I got VNO as minus 626.
minus 626.
Yes, sir.
Minus 626 angle?
Angle 0.
Minus 626. I think you should get 626 angle 180 then.
Sir,
Yeah,
sir, for VRN I got minus, sorry, 372 angle 180 degree.
correct. VRN is 372 angle 180 degree. Perfect. Next. So I'll write the answers here. VRN is equal to 372 angle 180 degrees. See, you have to be well versed with the calculator. You have to practice AC problems. If you leave AC networks thinking it is some tedious process involved, you will lose the marks. What if all the questions comes in AC networks? Clear? No, it is also a possibility. One of the possibility. You can expect all problem to be in AC network. Then you will lose completely. Correct? No. So you have to be thorough in all the concepts, and you will be using being an electrical engineer. You will be using calculators forever in your engineering degree in all subjects except management oriented subject. You will be using calculators. Clear? So you should quickly, like you type message in WhatsApp, you have to type values in calculator, complex numbers in calculator. Correct? No? You have to be very quick.
Sir,
Yeah.
VBN 784.48 angle 163.7.
Perfect. It is 784.48. Repeat.
784.48 angle 163.7.
163.7. Understood? Yes. Next, last one.
Sir, I got minus 163.78.
Which one? Minus 163.
Sir.
VYN or VBN?
Sir, oh, sorry, sir. VY1, sir.
You have found out VYN. Correct? No?
Sir.
Yeah.
Sir, for
VYN.
VYN, sir,
Ah,
777 angle 165.
check out who's this?
Sir,
Check out VYN again.
yes, sir, 777.1 angle 165.
Something it is wrong there. VYN. I have the answer like this, 784.48 angle minus 163.71.
Yes, sir, you're correct, sir.
Correct? No?
Yes,
Yeah.
sir.
Yes, sir.
Yes. Now this completes the problem. We have to write the phasor diagram. So we have to write the phasor diagram. Correct? So the reference, you can keep it anything. Okay, you can keep the reference as the first voltage. What is that first voltage? VRO. This is the reference voltage. Okay, let this be VR. VRO right here. So you can write the phasor for supply side and load side. So I will write it for the supply side first, and after R you will get Y after how many degrees? 120 degrees while rotating in RYB fashion. So this will be what? V by O. And after Y, so you will be facing what? B. That is VBO. So the angle between these two is what? 240 degrees. Clear? So like this is a phasor diagram on the supply side. Okay. Phase voltages. I'm plotting what phase voltage. I don't have currents. I'm plotting the phase voltages. Now you can plot the phasor diagram on the load side. That means you'll be plotting VRN, VYN, VBN with reference to the reference. So let me have some reference like this. This is what 0 degrees. So I have to plot VRN first. VRN. What is the value VRN? It is 372 angle 180. 372 angle 180. So at an angle 180 with respect to the reference, you will be getting what? VRN. Am I right here? So I think it's clear. VRN happens to be at 180 degrees from the reference. Next, after R, I should get Y because there is a phase sequence. So the value is 784.48 angle minus 160 degree, 163 degrees. So I will have a phasor which has to be measured in this minus 160 degrees. That means from here I have to measure minus 163 degrees. So this is 90, this is 180. So I'll somewhere here I'll get like this. So I'll write in a different color. Like this somewhere. Okay. So let this be VYN. Okay. Next, VBN. After I have to mark like this. I'll mark it here. This is minus 163 degrees. Minus 163.7. So whatever you measure anti-clockwise, that is positive. Whatever you measure clockwise, it is negative. Because my reference is what? RYB in anti-clockwise direction. Always the phasor rotates in anti-clockwise direction, we can assume it. Next, last one, VB. VB comes that is at the reference 160 degrees. So 163 degrees, somewhere here, I will write here, is VBN. The angle here is 163.7. So this is the phasor diagram. So is it clear? So if it is okay, please type 0 in the chat box quickly.
Sir, repeat this, sir.
Yeah, I'll repeat it. The RN is what? The phase voltage on the load side. It is 371 in magnitude at an angle 180 degree with reference. With respect to the reference. The reference is 0 degree taken. And from 0, you have to measure 180 degrees and plot the value. That is VRN. Understood? Hello?
Yes, sir.
Yeah. Next, VYN I
Yes,
have to
sir.
plot. Yeah, VYN I have to plot. What is the value? The value is supposed to be 784 at an angle minus 160 degree. So if you can measure in positive direction, that means you have to subtract 163 degrees from 360. Then you will get positive value. Or else measure that angle in clockwise direction at 160.7. That is nothing but minus 160 degree. Got it? Understood?
Yes, yes, sir.
Next, last one, VBN. VBN is 784.48 at an angle 160 degree in positive side. Positive means anti-clockwise direction only. So plot the vector at 163 degrees. That's all. Clear?
Yes, sir. Clear.
Yeah. If it is clear for everybody, please type 0 on the chat box quickly. Yes. Next, we shall move ahead with next type of unbalanced load. Next type of unbalanced load. So next type of unbalanced load is what? Three-phase, four-wire system. Three-phase, four-wire system. That means if you have a supply like this and if you have a load like this, you will be having neutral. You'll be having what? Neutral. That's all. So the neutral wire is the fourth wire. The neutral wire is the fourth wire. If you have got neutral, then you'll be having current. That is neutral current. Okay. So in a balanced system, the neutral current is 0. In an unbalanced system, the neutral current is non-zero. Okay. The neutral might have some impedance. The neutral might have some impedance. That impedance is called neutral impedance. The neutral might have some impedance, and that impedance is called neutral impedance, that is Zn, and it might carry some current. So this is neutral without impedance. This is neutral with impedance. Here Zn is 0. Here Zn is non-zero. Clear? Yes. So when there is current flowing, how to find the current? That In is equal to IR plus IY plus IB. So this is the neutral current. So, okay. So the neutral current is made up of all the currents in the phases. Okay. So the neutral wire will be always having negligible impedance. That is always, it is assumed to be 0. But in some cases, the neutral impedance is significant. Okay. So the start point of the load and the supply system will get connected and will be at the same potential. Okay. Then it is called shorted. So then neutral impedance is 0 here in the first case. So here this point and this point is shorted. So the neutral impedance 0. Okay. So in some cases the neutral impedance will be there as a result. So these 2 points are not shorted. Clear? So in case that is neutral of the load is connected to neutral of the supply through an impedance Zn. So here, what is that you have to do? You have to find out again the neutral shift voltage. For this kind of analysis, in the second case, this is the first case where Zn is 0. You can directly do the analysis. In the second case, you have to find out the neutral shift voltage. The neutral shift voltage you have to find out as before, that is VNO. You have to find out this one, that is nothing but the same formula what we have been using, but you have to add the admittance of the neutral. Right here it is VRO into YR and VYO into YY, VBO into YB divided by YR plus YY plus YB. And one more thing you have to add is the neutral admittance, that is YN. This is what you have to find out
in the case where the neutrals are connected through an impedance. And after that, you can find out VRN, VBN, and VYN as before. The formula you already know. That's all. Yeah. Any doubts here up to this point? If it is clear for you, you can type 0 in the chat box quickly. So this is what we have been discussing. Yes. So what I will do, I will just stop at this point. Okay. In the next class,